check. Online students, can you sounds? Online students, can you hear us clearly? Online students. So we were waiting a bit until everyone joined. So just like the physical students, I think stable in the YouTube live close to 250, and yes, in the Zoom also we have somewhere around 60. Yeah. So I think it's good to go now. Everyone who need to join today, I think have joined by now. So students in the YouTube live and Zoom, just confirm, can you hear me clearly? So altogether it's like 350 students, and I think not all are just after O levels, right? Just put a message on the chat. Not like you are not just, everyone is not after directly after O levels, right? That means just new to science. I don't think so. We can't have 350 students. 350 students just after O levels. I don't think so. Just put it. Just use the chat for a bit. I just need to know the composition. Like who are the students? Okay, some students are after Edexcel, I think, right? Some students are Mali. Some students are after Edexcel, I think, right? Anyone after Edexcel here? Yes, just Edexcel exams, right? Okay. Okay, so yeah. So just online students, just use the chat. I just need to know, like, okay, some students are from 29 A level, okay. So I just need to know the composition. There's altogether 350 students in the YouTube live, in the Zoom, and physically, I think. I just need to know who's after O levels, like Excel or Cambridge O levels, who's after local O levels, new to science, who are and who just changed the classes and just decided to join this. I just need to know the composition. Here, yeah, everyone after O levels, directly after O levels? No. What about you guys? Yes. Okay. So first of all, like, okay, just to come up with the plan. Now, if anyone is new just after O levels or Edexcel, I just have to talk about the reality. If anyone's entirely new or just after O levels or after Excel or something like that, they are like 3 months behind the existing students. Okay, they are 3 months behind the existing students, which is a problem. Okay, which is usually a problem, because I mean that 3 months gap will exist for a longer period of time if you don't do something. Okay, so if that 3 months gap continues, okay, if that 3 months gap continues for a long period of time, like it's not gonna affect A levels because there's enough time to catch up everything. It's gonna affect the first term test and all, right? Okay, because they may have done a lot of stuff for the first term test, okay, while you're a bit behind than that. Okay, so like getting the first term test secured should be the main target at the moment for the students who joined lately. Okay, that should be the target, because I mean, anyways, for A levels we have plenty of time. It's 2.5 years from now for the A levels. So it's about the first term test. Before that, we have to cover things. So that's why I changed the plan a bit. That's why we have given you the vectors tute. Okay. The reason is, what I'm going to do is, usually this lesson starts with units and dimensions and measuring instruments. Okay. Usually A-level syllabus starts with units and dimensions and measuring instruments, which are not very crucial lessons. The most crucial lesson is mechanics. And we begin mechanics, okay. We begin mechanics with actually vectors, okay. We usually begin mechanics with vectors. So by next week, I'm starting mechanics, basically mechanics for my Tuesday class. That is your main English medium class. Okay, next Tuesday evening. 3 to 6:30. There's an additional session from 6:30 to 7:30. If you like, you can stay. It is a difficult question discussion. Questions like Olympiad kind of stuff. So 3 to 6:30, the normal class, Tuesday evening. Then 6:30 to 7:30, you have the additional question discussion where you, if you like, you can stay for that session. Okay. So what we are going to do is I'm going to this Tuesday we are starting mechanics, hopefully. So this Tuesday you may find it a bit difficult, but by the Tuesday after that, everything will be resolved. I need you to join this Tuesday's class too, okay? Today what I'm going to do is I'm going to cover up the basic vectors concepts that you need to join this Tuesday's class, okay? Then with that concepts you can, without any issue, okay? Without any issue, you can continue mechanics, okay? Clear? You can continue mechanics. So you will be joining the main classes. So in some places you may go through a different program. Then later maybe get joined with the main classes, which I don't like to do because a 3 months gap is huge, okay? A 3 months gap is huge, okay? So you can't live with that 3 months gap for a longer period of time. Most probably until the first term test. Because if you don't do the first term test properly, that's where the teachers start judging you. All the problems start there, right? These 80% issues, everything, you know, right? All the problems come for the students who don't have marks, okay? Nobody cares whether the section first have 80% attendance or not. Nobody cares whether the class first have 80% or not, okay? Clear? Everyone is concerned if the class 49th have 80% or not, because everyone need that person to not to go to the exam, because the statistics of the school will go down. So that is basically how the schools use this 80% thing, okay? Yeah, that's how schools use this 80% thing. They are not using this 80% thing to block the class first or class second or class third. Okay, they are not gonna, they may, but their ideal intention is not to block the class top 10 students or top 20 students, not blocking them to blocking their access to the exams. The ideal target of this having 80% is if there's a student who haven't done work properly, if that person don't have 80%, it's a chance for the school, just block the person from A level, so that, I mean, you can keep your school statistics at a good level, okay? Because the fail count matters for the school, right? Okay, fail count matters for the school, pass count, pass percentage matters for the school. Okay, so that's how things happen, okay? So we can't live with a 3 months gap. That's why I directly planned everything such that you can join the mechanics session from this Tuesday, okay? All the new students, this Tuesday 3, you can join with the main class, okay? Without any issue, okay? For the basic theorems we need for that, I'll cover today. But that doesn't mean I'm going to finish all the vectors today. What I'm going to do is I'm going to cover the theory of vectors today. Instead of doing a lot of questions, what I'm going to do is I'm going to cover a lot of theory today. I'll do all the vectors theory today so that you would understand everything from next Tuesday. Then while joining the Tuesday class, you can come to the Thursday morning class, okay? While joining the Tuesday class, you can come to the Thursday morning class where I cover up things, okay? Clear? So 2 classes going to happen parallelly, okay? So catch up with whatever you have missed, and the best thing is you are not going to miss the main class, okay? You are going to go with the main flow, so there won't be a remaining delay with the main students, okay? Clear? There's no point of we doing units and dimensions and measuring instruments here faster. By then the normal classes would be maybe done with half of mechanics. Now all of a sudden when they announce, okay, for the first term test we are giving until this part of mechanics, now you are in trouble, okay? Now you have to all of a sudden cover up that 3 months gap. So that's not what we are going to do. What we are going to do is we are going to do parallelly. We are going to catch up things parallelly so that you can join the main class. So no gap would stay there from next week. Whatever the things you have missed at the beginning, we'll be covering in the upcoming months, okay? So first we are starting with vectors, okay? First we are going to start with vectors. Cover up vectors. So it may take 2 or 3 weeks to cover up vectors properly, do all the questions. We can't just quickly go through points and skip things. So it may take like 3 weeks to cover up vectors, to explain everything, to do questions and all. But from next week onwards, I'll do theory today in a way that from next Tuesday onwards, you can join the main class, okay? So that I need everyone to keep in mind. Next Tuesday, you have to join the main class, okay? Clear? That's how things are planned, okay? So for any online student who are not in the group or anything like that, can we put the number? Yeah. Any student who's facing any issues, not in the group, need to get the, I mean, there are a few stuff for online students. You have to get your tudes delivered. We are gonna start delivering tudes for you guys by tomorrow. So there's a separate process for you to get the tudes delivered where you have to text a number. But this is our main hotline, 070-154-6825. 6825, 070-154-6825. You can contact this number for recordings, to be added to the group, for any link or anything, any kind of a class related issue. You can contact this number. And like for tude delivery, there's a separate number. I'll give that information a bit later, okay? Clear? I'll give that information a bit later, the information you need to for tude delivery, okay? So let's start. Tudes are provided as a drive link for now if you don't have the tude, but by tomorrow we are going to deliver tudes. There's no any extra charge for tude delivery. You just have to send a message to the number we give, then we can send you the tudes, okay? Clear? Again, what is the time for the Tuesday's class? It is from 3 to 6:30. Tuesday evening, 3 to 6:30. Then 6:30 to 7:30, there's an additional question discussion. If you like, you can stay, okay? And another thing is, like this Thursday morning time slot, I don't know like how long we can do. Your schools may be starting, issues may like that may happen, but at least to finish vectors, we can use this Thursday morning slot. Then when your school starts, if you need to do more sessions, let's like talk and figure out a time for that, okay? Clear? Let's do it that way. Let's talk and figure out a time for that if your school starts quickly, okay? So until at least then, until we finish vectors, we can go with the Thursday morning session, but you have to inform, okay? If next week your schools are starting, just let me know, okay? Clear? If something important starts happening at the school, okay? These days, I think some orientation kind of stuff, additional stuff may be happening at the school, which is entirely useless. But I mean, if important stuff starts happening at the school, okay, just let me know, okay? Then we can arrange something, some additional time or something like that, okay? Yeah, so all the information will be provided, okay? All the information will be provided. For now, I mean, if you need any other information, just put a message to this number or give a call, okay? So let's start the lesson. Vectors, and like again for Edexcel students, you may be facing some new issues like you can't use the calculator anymore, so you have moved like back in time. You have to use the logbook, so new problems may occur. For that, we'll be doing some additional sessions, okay? We'll be doing some additional session because local A-level is planned in a way that local O-level students could continue. There's a small like issues like not using the calculator kind of stuff when you're moving from Edexcel to local A-levels. For those to resolve those issues, a series of small sessions would happen, okay? So don't have to worry about that. And yeah, that's mainly all the plans and ideas. If anyone joined late, the YouTube live link is anyways available in our channel, so you can watch the initial part and the introduction and how things gonna happen, okay? So starting with the lesson, okay? Today's lesson is vectors, okay? We are gonna start with vectors. So like talking about vectors, these are physical quantities. Physical quantities are anything that can be measured. Like physical quantities are mass, length, time, temperature. Okay, all these are physical quantities, and there are different levels of physical quantities. Okay, what is these different levels of physical quantities? Take for an example mass, 5 kilograms. Okay, this box is 5 kilograms. You don't ask any additional questions after that, right? This can be considered as a complete information. The mass of this box is 5 kilograms is a very complete information, right? Clear? Okay. Or else if we tell like the temperature now is 30 Celsius. A very complete information again, right? Again, a very complete information. Okay. No one asks anything else, right? If you tell, okay, the temperature now is 30 Celsius, no one asks anything else, right? It's a complete information. But if I ask you to move this table, 5 meters, you may ask another thing. In which direction? You may ask another thing, in which direction? Clear? So when I tell this, the mass of this box is 5 kilograms, a complete information. The temperature currently is 30 Celsius, a complete information. But if I ask you, I mean, if there's a table, okay, if there's a table and if I ask you to move this table by 5 meters, you may ask in which direction, right? You will definitely ask in which direction, okay? So this 5 meters is not a complete information in that case, because it need not only the magnitude, but the direction too, okay? It need not only the magnitude, it need the direction also, clear? We need two information, okay? Clear? So, there are many other examples like that. Maybe force, okay, just apply 5 newtons. I'll take this later actually. Okay, this you understood, right? Okay, so some physical quantities you need the direction to be defined, okay? So there are some physical quantities, the magnitude would be enough, okay? The magnitude would be enough for some physical quantities. In that case, when the magnitude, we call them scalars, okay? Scalar quantities. Then for some physical quantities, you need the magnitude and direction both, okay? You need the magnitude and direction both. For them, we call vectors, okay? Clear? There are some physical quantities you have to introduce not only the magnitude, you have to introduce a direction too, to be able to understand that properly, okay? I mean, this is not all, okay? These we call vectors. So this is our main topic. This is what we have in our syllabus. But that's not all, okay? That's not all. There are like 10 different levels for physical quantities. Not actually 10. You can go for further higher dimensions too. Okay? It's very complex. That means for some physical quantities, even the magnitude and direction would not be enough. For some physical quantities, you may need like 1,000 other information to understand. Later, for some physical quantities, we needed further dimensions. Einstein physics. Okay? So, there are different levels for physical quantities. Okay? For an example, I'm not going to go into Einstein physics. Just think about force. 5 newtons. Still, 5 newtons. And I'll give you the direction. In this direction, still not a complete information. Still not a complete information. 5 newtons in that direction, it is still not a complete information. Why? What is the reason? I mean, you have a pen like this. Now, the question is, now what we are telling is, we are asking you to apply 5 newtons on this pen in that direction. Okay? We are asking you to apply 5 newtons in that direction on this pen. Now, what is the problem? Now the next question is, where? On which point of the pen? On which point of the pen? Because otherwise the final result or the meaning would change, or what happens would change, right? If you apply the 5 newtons to the middle of the pen, it may try to go in a linear manner like this. Clear? If you apply these 5 newtons to an end of the pen like this, clear? While moving forward, it may try to rotate a bit, right? Clear? Clear? If you apply these 5 newtons to this end, if you apply these 5 newtons to this end, it may try to rotate like this, right? It may try to rotate like this, clear? Okay, so like that, certain rotations may happen, okay? And I mean, you don't know, see? You don't know what is going to happen. That means you won't have a complete idea, okay? You won't have a complete idea on what is happening unless they give you magnitude, direction, and another information. What is this information? What is this information? We call that the point of action. Where, on which point are we applying the force? Okay. For an example, the force, I mean, if you walk 5 meters in that direction and 5 meters in this direction, the result is certain, right? You are gonna return to the starting point. If you walk 5 meters in that direction, 5 meters in this direction, the result is, I mean, you have a complete meaning. You have a complete meaning because you know you are going to return to the starting point. But now see, if we tell that we are applying, 5 newtons, okay? If we tell that we are applying 5 newtons to an, I mean, we are applying two forces like this, 5 Newton and 5 Newton. If we apply two forces like this, okay, 5 Newton and 5 Newton, okay, on this object, result varies, right? Result definitely varies. Why? If you apply 5 Newtons and 5 Newtons like this is not going to move, right? This is not going to move. Clear? But if you apply these 5 Newtons and these 5 Newtons like this, it's going to rotate. It's going to rotate. See? So without the point of action, where you should apply the force, okay? Without the point of action, it's not going to be meaningful, okay? It's not going to be meaningful without the point of action. Clear? Clear? It's not going to be meaningful without the point of action. See? There are like higher levels of vectors now. So this is a vector, yes. Force is a vector. You definitely need the magnitude and the direction. But even with the magnitude and direction, force is not complete. See? For the force, you need some other information to understand. Clear? Like this, there are like 1,000 different levels for physical quantities where you need more and more information to understand. Okay? Clear? Where you need more and more information to understand. Clear? I mean, for some physical quantities, we haven't been able to understand yet. Like gravity is a physical quantity, gravitational field intensity. The gravitational acceleration you feel when you release this, it falls, right? That's gravity. Still, we haven't even been able to understand properly, okay? Clear? Scientists think that there's a particle called graviton which decides this, which we haven't been able to find yet, okay? So some physical quantities we haven't been able to figure out yet because we need more information. We need more information about gravity. All we know is, yes, it has a certain value. When you release it, it may fall like this. You know a certain stuff, but you can't control gravity, right? We can't control gravity. Why? Why can't we control gravity? Because we don't have enough information. You can control a force because you know what decides the result of a force. Magnitude, direction, point of action. So you know, okay, if I change the magnitude, you can do this and that. If we change the direction, we can do this and that. If we change the point of action, it may behave in different ways like this. So you know. So you can control anything using a force. But gravity, we can't control. Time, not exactly. Why? Still haven't figured out all the information required for them. Okay? Clear? When you figure out all the information required for gravity, then you can control gravity. When you figure out all the information required for time, you can control time. That's what I mean happens in, you may have watched Interstellar, right? Yes or no? No, right? I don't think so. Interstellar? Really? You're not fans of Christopher Nolan? No one? No one Interstellar? Only one student? You watched? That's all. Okay, two. Okay, it is always there at IMAX, I think. Okay, they like once a month they show that. So just watch, okay? Nice scientific movies. So that's what they try to figure out in the movie Interstellar, the equation for gravity, right? Equation for gravity. These are movies like, I mean, usually everyone have watched, okay? You can't like, you have you watched cartoons at least? Yes, right? Okay. Uh, no, nowadays the kids don't know like what are cartoons. Smaller ones, you just go and ask. Smaller ones don't know what are cartoons. Some students, they know how to go to Netflix, YouTube, anything. They don't know that something called cartoon exists. They don't. I think they don't call them cartoons. That's why they are different names for that. Maybe. Okay. So, anyways, so like moving here, vectors. So under the topic vectors, okay. Under the topic vectors, what we are doing is we are gonna understand, okay. Under the topic vectors, what we are gonna do is this is a new domain of mathematics, okay. A new domain of mathematics. So in normal maths, you know, you first did introduced, then you learned the symbols to write numbers, then you learn to how to do calculations with them. Like that, there are a set of things happen with that, right? The same thing we are going to do with vectors. So we are going to learn this new domain of mathematics. We are going to learn the definition, then we are going to learn how to represent them, then we are going to learn how to do calculations with them, like that, okay, clear. And at the same time, some students after O levels maybe have a small doubt of whether I'm capable of doing A level science or not, kind of stuff some students may have. Just entirely forget that problem, okay? Because A levels, these kind of exams, like the national exams, are for general people. General people means the people with a normal brain, okay? This is not Olympiad or anything like that. Olympiad exam specifically designed for intelligence. You can't just do a lot of work and pass Olympiad. You have to see things. Okay, there are people who can see things. You see a question, you see the answer. You don't know how that happens, but you see. I mean, even in every class, I have a set of students like that. When they see a question, they see the answer. Even they don't have a very good clarity about how they got there. Okay, clear? So Olympiad kind of some exams are planned for that. These we don't have that kind of a problem in the country to figure out that kind of intelligent people. They anyways go out. So A level is just for general people, people with a normal brain. Okay. So anyone in the country, okay, if you are not disabled or mentally disabled or anything like that, okay, if you don't have that kind of issue, anyone with a normal brain can do A levels, get 3 A's, and do this well. So it's entirely proportional to the amount of work you do. That's all, okay? So whatever your O-level results, we can't, using O-level result, we can't predict anything. Why? Many of the students, especially guys, you didn't actually work for O-levels, right? Okay, so if a student is there who got a weak result for O-levels, and when that person come to me and ask, okay, will I be able to do science? The question that I usually ask is, did you work for O-levels? In many cases, no. They haven't done anything for O-levels. Only in the last 2 months they have worked and they have got a result, okay? So for a person like that, how can I tell if the person worked for two years straight, what would happen? We can't tell, okay? So your O-level results have nothing to do here, clear? O-level results have nothing to do here, cannot decide. You don't have to have that doubt, okay? Because entirely these are different, okay? You actually don't need O-level maths a lot. You don't need O-level science a lot, okay? Because anyways, O-level science and math syllabus, it's like 0.01% of our physics syllabus, okay? Clear? This is huge. So if you were good at or if you were bad at, it is just 0.01%. Other 99.9% you have to learn new. So won't matter, okay? It won't matter. So your O-level results, if there's any student who has a doubt, okay, I didn't perform very well in O-levels. Will I be able to do A-level science? Yes, because I mean, there's no actual connection between O-levels and A-levels, okay? Clear? It is just a general exam made for anyone who work in the sense who work very hard straight for 2.5 years. Okay, because these engineering and medicine, these are the two main things like that students get into after doing A levels, right? Are not a matter of intelligence, right? Engineering and like medicine is about always like persistence and discipline. So that's what usually they check in A level 2 years. Okay, clear? You just have to do a lot of work for 2.5 years continuously without any break. Then you get the result. Otherwise, you are not going to get the result no matter how smart you are. Okay, so that's the nature of A level exam. So don't think about O level results or anything like that. Okay, this is just a general exam made for anyone. We don't have any actual difficult exams in the country. Okay, even the National Olympiad is a simple paper. Okay, if you like, you can go and try. National Olympiad paper is simple. International Olympiad, that's a real exam. Okay, clear? So let's move forward. So talking about vectors, now we know the definition of vectors. Okay. Okay. Now we know the definition of vectors. Now how to represent a vector, how to identify that something is a vector. We just draw a line. As I said, the vector has a magnitude and a direction. So this line should have the length. This line should have the length of that vector. That means the length of this vector represents the magnitude of the vector. Clear? Length of this line represents the magnitude of the vector. Clear? And we can give a name like A to that vector. Okay. But to represent that it is a vector, we just draw a line. We just draw a line underneath that. Okay. This is okay. This is the vector called A. Okay. This is the vector called A. Now, if this is the starting point A, if this is the final point of B, we can even call this vector as AB. That means the vector which goes from A to B. Clear? We can call this vector AB, the vector which goes from point A to point B. Okay. This we call vector AB. Okay. So these are different ways that we represent vectors. Okay. Clear? That means assume you need to represent a vector on a piece of paper. You need to represent 5 newtons on a piece of paper. How can you draw 5 newtons on a piece of paper? You can't draw newtons on a paper, right? So what we do is you just have to use a scale. Maybe 1 newton means 1 centimeter. Like that, you have to have a scale. Okay. You first have to have a scale. 1 newton equals 1 centimeter, like that. Then according to that, 5 newtons will be 5 centimeters. Clear? Okay. Now they may give you the direction. Okay, this is the direction. Okay. Now what you do is you draw a line in that direction. You draw a line in that direction with a length of 5 centimeters. And to show that this is a vector, we use an arrow like this. Clear? To show that it is a vector, we are going to use an arrow like this. Clear? Clear? So this means a vector going in that direction which has the magnitude of 5 newtons. Clear? That's how you represent a vector completely. Clear? Okay. This is how we represent a vector completely. Now, like other stuff maybe. That means there's a term called, first, if we have to so this is a vector 5. Just to show that it is a vector, I'm going to draw a line. So we draw a line like this to show that it is a vector. Okay. Clear? So now to show that something is a vector, we use these symbols. And if someone asks you the magnitude, okay, if someone asks you the magnitude of this vector, we can tell like this. This is how we represent the magnitude of a vector. One way is this length of this line represents the magnitude of the vector. Or else we use this symbol to show that it is the magnitude. So if you see a symbol like this, the meaning of that is This is the magnitude of vector A. Okay. Meaning of that is this is the magnitude of vector A. Clear? This is the magnitude of vector A. Or else we write A. Okay. Magnitude of vector A is A. Clear? Or else we can tell maybe vector AB. This is the vector going from A to B. Magnitude of vector AB is the length AB, right? Just forget the direction and get the length. Magnitude of vector AB. AB with this line means it is a vector. Magnitude of vector AB is AB, okay? Here, magnitude of vector AB means AB. Okay. Then, after that, like these are the ways that we can use to show the magnitude of a vector. That means in this case, the magnitude of this vector 5 is just 5, okay? Magnitude of this vector 5 is just 5, clear? That's how we show the magnitude of a vector. Then again, some other terms, there's something called negative vector, okay? There's something called a negative vector, okay? What is a negative vector? What is a negative vector? A negative vector means, okay, a negative vector means a vector equal in magnitude. For this, they are equal in magnitude, but only opposite in direction, okay? That is a negative vector, clear? A vector equal in magnitude, so the same 5, but in opposite direction, clear? But in opposite direction, clear? Okay, same vector, but in opposite direction. That's what we call the negative vector of something, okay? So in this case, it will be like for this one, this is the negative vector. This is point A, this is point B. The negative vector has a opposite arrow. We call that minus A. Minus of vector A, which means the negative vector, or else we can call that the vector minus of vector AB. Minus of vector AB. Here, we call that the minus of vector AB, which is basically vector BA, right? Here, which is basically vector BA. Clear? Minus of vector AB, which means basically vector BA. Clear? Minus of vector AB means the vector going from B to A. Clear? See, negative vector is actually going from vector B to vector A. Clear? So that's how we do things in this domain. Now, you may have understood, okay? You may have understood like there are like, now we know a few stuff about vectors, how to represent them, the magnitude of them, how to get the, I mean, when you were learning normal number systems, you learned about numbers, symbols, then you learned about negative numbers. We are just doing the same thing, okay? This is just a new domain of mathematics, that's all. So we are, you know, maths people, who's doing mathematics? Who's going to plan to do maths? Okay, so you may like be doing differentiation, integration kind of stuff, right? Okay, a bit difficult mathematics stuff, okay? Differentiation, integration kind of stuff. Even in vectors, when we move forward, maybe at the university level, you have vector differentiation, vector integration. So this is just a new domain of mathematics, and everything you do in normal maths with normal numbers, you can do with vectors, but with new rules, okay? Clear? With new rules. Okay. So now we know we define a few stuff. We define the symbols, we define how to represent them, we define what is negative in a vector, the meaning of negative in a vector. Okay. Now we are going to do vector calculations. So what was the most basic calculation you learned with usual numbers? Most basic calculation you learned with usual normal numbers, it is addition, right? The simplest calculation we do is addition, right? So how to do an addition for vectors? How to do an addition for vectors. Okay. Okay, some other questions are there. I'll answer them later. Okay, because I have already started the lesson, so we may have to move a bit forward. And anyone who joined late, you can just get the YouTube live link. Okay, you can get the YouTube live link or just put a message to our number hotline and just clarify whatever the issues you have. Not 70-154-6825. And don't ask physics from this number. Okay, these people don't know physics. There's for physics, we have a separate invigilating program going on. For physical students, there are 2 days where you can come to the institute. As I remember, Thursday and Sunday, full day. Whenever you need, you can come to the institute and ask questions from any subject you have issues with. Okay, clear? Whatever the subject, from all 3 subjects you are doing, you can ask questions on Thursdays and Sundays. Okay, and for online students, a similar program is happening through Zoom. Okay, clear? So just join the group. All the information will be posted on the group today. Okay. Okay. So don't ask physics from this number. For that, there's a special invigilating program happening every week. Okay, this happens every week until A levels. Okay, because now you may not have problems. Sooner you may start having a lot of problems. Okay, I can't understand this. I can't understand that. Okay, so you have to come to invigilating sessions, you either physical or online, and clarify them. Okay, so now moving forward, doing calculations is with vectors very simple, and the equation we use and the concept we use for that is, the first concept is vector triangular theorem. Okay, vector triangular theorem. Everything is included in your tutor. Okay, clear? So you don't have to write anything at the moment. Vector triangular theorem. What is vector triangular theorem? Assume you have one vector in this direction and another vector in this direction. Okay, quite simple. Just think about walking. What happens if you walk in this direction, then walk in this direction? You actually go from here to here, right? Clear? Clear? If you walk in this direction, then after that, if you walk in this direction, what actually happens is you walk from here to here, right? That is the final result, right? Here, if you walk in this direction, then after that, if you walk in this direction, what actually happens is you went from here to here. So that is the meaning of a resultant vector, right? Addition of 2 vectors means what happens as a result of those 2 vectors. Clear? What happens as a result of those 2 vectors. Clear? So this is vector triangular theorem, a very simple thing. Okay, this is vector triangular theorem, a very simple thing. You draw one vector from where it ends. You start drawing the other vector. Clear? Then to complete the triangle, you draw another vector. That gives you the resultant. Okay, clear? That gives you the resultant. Again, for an example, if there's a point like this, if you apply 4 newtons in this direction and 3 newtons in this direction, clear? If you need to know the resultant, what you do is you apply vector triangular theorem, which means you get one vector, you draw that vector according to vector representation. You draw that vector according to vector representation 4. Clear? Then you get the next vector. Okay, then you get the next vector 3 newtons. Okay, you get the next vector from where this 4 newton ends, you apply that 3 newtons. Clear? You draw the next vector. Clear? You draw the next vector. Clear? Now this gives you a resultant like this, right? This is the beginning of your triangle. This is the end of the triangle. Clear? Then the resultant is this, right? Clear? The resultant is this. Okay? So 4 and 3. I mean, this is a triangle. So what is this? R squared equals 4 squared plus 3 squared, right? R squared equals 4 squared plus 3 squared. Clear? Then what? 16 and 9, which means 25. 25 means 5 squared. So R means 5, right? R means 5. Clear? That means you applying 4 newtons and 3 newtons is entirely equal to you applying 5 newton in a direction like this, okay? That is the meaning, okay? You applying 3 newtons and 4 newtons separately in this direction and this direction is entirely equal, okay? It is entirely equal. You applying 5 newtons in this direction, okay? Clear? That's how it works. This is vector resultant, okay? This is how we get the resultant of a vector, okay? And there was a question like what happens in mechanics, like maybe from next Tuesday. So these things you have a good clarity, like motion graphs, these stuff you have worked with, right? You have worked with motion graphs, right? Velocity diagrams. So it's going to be like that. So mechanics initial parts going to be somewhat familiar, okay? Things you learned at O levels. Then only we move to the difficult parts. Okay? Is it clear? Okay? Let's do a few questions quickly. Go to your book. Provide the drive link. Drive links will be available if you don't have the tute. Provide the tute in the group. Tute in the group. Tutes are available in the group. Tutes are available in the group, in the YouTube live chat, and in the Zoom chat. Okay, if you don't have the tute, can I have the tute delivery number? And tute delivery number will be provided now. I'll put that on the board. You can get the tutes delivered by contacting that number, by putting a message to that number, okay? We'll be sending you the tutes within like 4 days, okay? So ideally, before next week's class, we expect you to get the tute, okay? There's no any additional payment, just put a message. So yes, about your notebook, don't keep any space for initial lessons. Just start with vectors and use this book. Just use the notebook from beginning. Start with vectors. And I asked you to join next Tuesday's class. Maybe like leave 10 pages for upcoming vectors, 2 days. Maybe leave like 15 pages for upcoming vectors. Then just write on the same book from this Tuesday, okay? Clear? Otherwise, you are going to just mix you may have like a lot of books, okay? Okay, then later when it is close to A-levels, you may not know which book to use, okay? Because this is not like O-levels, you may have to do a lot of stuff. That's why I usually give everything printed on the tute, okay? Because otherwise, when you lose books, these things every year, these things happen. When it is very close to exams, the people start asking for a note. Now they all of a sudden they have lost their note. They can't figure out the order of the note. A lot of problems. So that's why I usually print everything on the tute. Sometimes we write a note, but still that is also available on the tute, okay? So the basic thing is just protect your tute. Then you will have a note to study when it's time for A-levels, okay? Clear? But I mean, there are like some students may need to write everything again for it to remember, right? Here. So you just can go home and write everything, okay? Just look at the book and write everything, okay? I'm not going to do that in the class. We are going to use all the time to do questions, okay? So I'm not going to write very lengthy notes in the class usually. That's not how physics works. For physics, so you need practice. You never study anything for physics, okay? So no point of writing everything if you are not studying. You just need practice through questions, okay? So what we are going to do is we are going to save all the time to do questions, okay? And you will have a perfect note printed from our side, clear? Then if you even lose the note, we can again give you the note, right? Otherwise, if you lose your note, I can't give that note, right? Okay, that usually happens after 2.5 years, where you all of a sudden you start remembering, okay, now I need notes to study. Okay, so let's move to questions. Drive links are available. Go to that tute. Maybe on page 5 there's a set of short questions. Maybe try question 13 on page 5. On page 5, question 13. Question 13. Question 16. Question 20. Do in this order, page 5 on your vectors tute. Question 20. Then maybe question 14. Question 14. Go through these questions. Online students, if you have any questions, put a message. And tute delivery number would be 070-786-6277. So what we need you to do is to get the tutes delivered, put a message to this number. When you are putting the message to this number, mention whether you are a English medium student or a Sinhala medium student, and just mention you are a new student. Then our people know what to do, what are the tutes you need to get, because you don't know what are the tutes you need actually, because there's a 3 months gap. So we need to send all the content you missed. Then with us, you can keep doing, you can keep covering the things you missed. So we have to send you everything required for next 1 month, and everything happened in the previous 3 months. We have to send you the tutes. So just mention, put a message to this number. I think we need your address and the phone number. With that, mention that you don't have to mention the tute you need. That just mention that you are a 2028 English medium or Sinhala medium. Mention the medium and entirely new student. Okay, then now people know what to do. That is for tute delivery. Live students, you can use the chat. Okay, if you can't find the tute or anything, and even in the description, you can find the tutes. Okay, even in the description, you can find the tutes. If not, just put a message. just don't leave any pages for the missed note. Just start writing from this point. Just put the topic vectors, then just start doing questions. Okay, in our class, what we are going to do is, in your main books, what we are going to do is, like 99% of the time, just doing questions. Okay. If they mention about two vectors, draw one vector. Then from where it ends, draw the second vector. Then use whatever the theorems you know to get the resultant. Okay. For an example, in question 13, it is 5 newtons and 12 newtons act in 90 degrees. So, see, it's 5 newtons and 12 newtons acting 90 degrees. So, this is going to be the resultant, right? Like that. Okay. Just get the answers. And it's very practical, right? Vector triangular theorem isn't any something complex or like very mysterious, right? It's just practical, right? If you walk 5 meters in this direction, then after that, if you walk 12 meters in that direction, what happens, right? That is the basic question. Okay. Yeah. So it's very, anyways, very straightforward. Okay. Okay. Like if you try a few questions, like some questions are very straightforward. Question 13. Question 13. Two vectors of magnitude 5 newtons. There's one vector, magnitude 5 newton. And there's another vector, magnitude 12 newton, which are entirely perpendicular. Another vector, magnitude 12 newton, which is entirely perpendicular to that. Find the magnitude and direction of the resultant. Find the magnitude and direction of the resultant. So here we have 5 newtons. So this is vector triangular theorem. You first draw 5 newtons. Then this is where it ends, right? This is where it ends. Then you draw 12 newtons, okay? Then you draw 12 newtons, clear? You first draw 5 newtons. Then it ends here. Then it ends here. Then you draw 12 newtons, clear? Then the resultant is, how the vector triangular theorem works is, this is the beginning of the vector. This is the end of the vector. Then the resultant is this, right? This is the resultant, right? And don't need to do a lot of calculations. You know that 5, 12 and 13 is a combination, proper combination for that satisfy this theorem, right? The Pythagoras theorem, clear? Okay. This 5, 12 and 13 is a proper combination, right? 13 squared equals 12 squared plus 5 squared, right? So it works. So directly the answer is 13 in this direction, okay? 13 this in this direction. But actually when you are giving an answer, okay? Actually when you are giving an answer, it's not 13. It's not just 13. If this, it's good to represent the angle also. Because vector, in a vector, it's about a perfect direction and a magnitude, okay? Clear? In a vector, it's about a perfect direction and a magnitude, okay? So magnitude we know, right? Using 5 squared and 12 squared equals 13 squared, you know the magnitude. But I mean, you can't just tell, okay, this is the direction. Okay? You can't just tell, okay, this is the direction. Then someone can tell, no, it looks like this. Someone can tell, oh, no, it looks like this. So when you are answering in a paper, you have to properly define this theta. Then only we know the actual angle, okay? You have to properly define this theta as an angle, maybe 30 degrees, maybe 22.0 degrees, like that, okay? So how can you find theta? Maybe use tan theta, or maybe use sin theta, or maybe use cos theta, then use the logbook, right? Okay, that means you can find tan theta here. How? You can find tan theta here. How? How can you get tan theta? Tan theta means this over this, right? Tan theta means this over this, clear? 12 over 5, clear? Tan theta is 12 over 5, clear? So tan theta means 12 over 5, okay? We can tell tan theta equals this over this, 12 over 5, clear? So now I mean, you know how to use the logbook to find the theta given tan theta, right? Yes or no? Some people, yes. At Excel. Okay, at Excel people, you don't know, right? No big issue there. We can solve that. I mean, O-level, local O-level people, you know, right? If that, no, that's not, that is an issue. Okay. Okay. So, what we do is, so how to use a logbook, okay? How to use a logbook and everything will be done. Maybe by next week, we'll be able to do some stuff about that. Okay, for now, I'll just use the calculator, okay? Mali, calculator. Okay, so what we are going to do is we are going to properly define a tan theta, okay? We are going to properly define a theta. And just for, I mean, for the sake of now, if you like, you can write theta like this, okay? Theta equals tan inverse 12 over 5. Okay? This is just a notation, just a mathematical notation. the meaning of this is theta is tan inverse 12 over 5 means tan theta is 12 over 5. Okay, clear? Clear? That means like if sine theta is 0.1, okay, you can tell theta equals sine inverse 0.1. Theta equals sine inverse 0.1. This is just a notation. If you see theta equals sine inverse 0.1, that means sine theta is 0.1. Okay. If cos theta is 0.7, you can write theta equals cos inverse 0.7. Okay. Clear? That means cos theta is 0.7. This is just a notation that we usually use. That means whenever you don't have enough time, okay, assume in a paper, if you don't have enough time to finish things, okay, if you don't have enough time to finish things, just write it like this, okay, just write it like this, okay, but not always, okay, not always. If you don't have enough time, just put this notation and finish things, okay. So here we get 2.4. Tan theta equals 2.4. Now you have to use the logbook to find theta given tan theta is 2.4. Okay. So we can write tan theta is 2.4. Then theta is, use the logbook, 67 degrees. And that session's happening for Excel students. Even the local students can join, okay, if you are not very familiar with the logbook and all. Because I think you had the ability to skip the logbook if required, right? Yes or no? Skip the log question in all levels, okay? Okay, so you can even join, okay? So clear? Now only this is a complete answer, okay? Now only this is a complete answer. The resultant is 13. Resultant is 13. And for a complete answer, you have to put the unit. It is newtons. 13 newtons. And what is this angle? What is this angle? 67 degrees and 23 minutes. Now only this is a very complete answer, okay? You get marks for the magnitude. You get marks for the unit. You get marks for the angle. Because I mean, this makes sense, right? You need all this information to understand this. Because just telling 13 won't make any sense. Why? 13 of what? But just telling 13 newtons won't make any sense. Why? In what direction? See? So this only provides you with all the information required. Okay? Clear? So let's move forward. Let's move forward. Yeah, it's a good question. You can invert 12 and find no big issue. In vector calculations, order doesn't matter. Just like in other calculations, order doesn't matter. That means you can first draw 5 and 12 or first draw 12 and 5. Okay? Okay, you can first draw 5 and 12 or else draw 12 and 5. Why? See, you first draw 12. You first draw 12. Okay? First draw 12. Then after that you draw 5. Still you would get a similar answer. Okay? Still you would get a similar answer. Clear? Okay? Let's move forward. Okay. Just download the PDF, then you would see the whole tute. Or else just join a group. Join the group. It will be available in the group too. Is it resolved? From the drive, download the tute. Okay, next. Question 16. Question 16, a similar question, right? Question 16. A particle has velocity component 3. A particle has a velocity component 3 to the east. You first draw that one. Then from where it ends, you draw the next vector, which is 4 to the north. 4 to the north. 4 to the north. Clear? Then the resultant would be this, right? Resultant would be this. Clear? A particle has a velocity of 3 in this direction. Then after that 4 in this direction. Then this would be the resultant, right? Clear? Which is 3. For 3 and 4, it's going to be 5, right? For 3 and 4, it's going to be 5. Okay? But again, define the angle properly. How? Maybe write tan theta. Maybe write tan theta. Tan theta here means 4 over 3. Tan theta here means 4 over 3. Okay? Tan theta is 4 over 3. Okay? Then it's going to be 1.33. It's going to be 1.33. Okay. It's going to be 1.33. Tan theta is 1.33. So now use the logbook. Okay. Now use the logbook. Theta is 53. And something like 4 minutes. Clear? Okay. Now only you have a perfect answer. How? Now the answer is like this. This is the resultant. This is the vector representation of the resultant. It is going to be 5, not just 5. You have to mention what is that. It is a velocity. It is a velocity. So the unit is meters per second. Unit is meters per second. Then you have to tell. Then you have to tell what? Then you have to tell the angle from east. Angle from east, which is 53 and 4 minutes. This is a perfect answer. Clear? This is a perfect answer. Next. Question 20. Question 20. Question 20. Question 20. The minimum resultant of two forces is 16 newtons and the maximum resultant of two forces is 40 newtons. When they act at 90, find the resultant. So how can we get the answer? What is the minimum resultant and maximum resultant? They are not giving the angle between them, right? They are not giving the angle between them. They are just telling the minimum resultant is 16 and the maximum resultant is 40. Okay. And I mean, I hope like all the new students joining, especially online, you are here to just actually learn physics, okay? Because I mean, not just to like learn, like on the first day to learn 10 names of physical quantities, then study them, okay? Then tell them in order, then write them in order, then okay, let's write the symbols for them, then let's try to remember that. I hope you are not here for that, okay? Clear? Because I mean, I just start physics and I just keep teaching physics. Otherwise, we can't survive. Okay, this is a very highly competitive. I mean, you know the statistics, right? Hope you know the statistics. That means all the like in science, all the students who worked at least slightly better you have in science, right? Here, the worst person you knew in O-level class is not here, right? Okay, in your okay. So the people who at least slightly did better in O-levels are in A-level science, right? Clear? So usually we have a good set of students. Out of that good set of students, that means a large number of 9As people, only 6% get an A pass for physics, okay, in the country. Only 6% get an A pass for, so remove all those other people. We have all the good people here, usually survived in O-levels, right? Usually the people who survived in O-levels. You don't have a fail for science or maths and you are here. It's not like that, right? All the good people are here. Out of that, only 6% get an A, okay? Out of that, only 6% get an A for physics, and close to 70% in the country, close to 70% of the country get either a fail or a S, okay? Clear? Okay, get a fail or a S. I mean, a lot of teachers like hate for me to tell in these statistics, but I mean, that is the statistic, okay? So if you want to leave, okay? Not the class, the science stream, okay? So these are the statistics, okay? These are the statistics. That's what make you at the end of the day employable, okay? Today job markets are very complex, so doing as other stream, there's a very high chance you would get 3 years, go to the university and still not get a job, okay? In other streams, because more pass rate means more people competing for the job, lower pass rate means a lower number of competing for the jobs, okay? So this has a better survival rate in these two. This has a lower survival rate in 2 years, but a better survival rate in the long run. That's science stream. Okay, the meaning of science stream is a very low survival rate in these 2 years. 70% fails or get a S, 6% get an A, but in the long run, after maybe 5 years, when you are seeking for a job or when you are starting something of your own, you have a better survival rate. Because you don't have a large pool of people competing. It's not possible. Okay, so that is the nature of science stream. So it's going to be always a lot of work. It's going to be always a lot of work. It's not like, okay, we write a small note, then you study that, okay, then you learn about a very simple measuring instrument, we study that. It's not like that, okay? It's going to be a lot of mathematical, lot of calculations, lot of thinking, everything would be involved, and from the first day I'm going to do that, okay? From the first day I'm going to do that. So I assume that none of the people here are just for the fun. I mean, okay, we are doing science and just to be bettered, okay? Clear? Then you are in trouble. Because I can do that in the first 2-3 days until you get stable in science, until you start liking science and stay in science. But it's not something ethical, okay? It's not something ethical. It's not actually a good thing to do something like that, okay? You have to see the reality of science, okay? You have to see the reality of science. If it is difficult, it is difficult. You have to face the reality. Yes, there's a lot of maths from the day one. There's a lot of work to do from the day one. So it's a lot of work from day one. And it's going to be like that for 2.5 years. So it's going to be a lot of work. It's going to be difficult. But in the long run, you're going to survive doing science, okay? That is the thing about science, okay? So especially this lower pass rate is due to the tuition system, okay? Why? We just don't show students the reality. On the first few weeks, we just take the students through a very light path. Don't show any numbers. Just write some units, then ask you to study them. Write another set of units, ask you to study them. Next day, give a paper so that you can write those units, okay? This culture in tuition industry where we don't show you the reality of science until you get settled. That culture is the main reason for that very high fail rate. Okay, clear? We in our class we usually maintain a 50% A percentage and a 100% pass rate. Okay, it's not that because I'm really good. It's because from day one I show the reality, so the people who need to leave early. Okay, clear? That's the reason. Okay, clear? That's what I usually do. Okay, we have a 100% pass rate and a 50% A pass rate when the country has a 6%. Not because I'm really good in teaching. The main reason is I just show the reality from day one, keep doing the difficult stuff from day one. So the students who think, okay, the science is not for me, just feel free to leave, okay? Because I mean, that is science, okay? But the thing is, it's the better choice is to somehow stay in the stream. Better solution is to somehow stay in the stream because it's going to be a lot of work, lot of difficult stuff for 2 years, but after that your life is going to be easy. Maybe for next 40 years until you die. In the other streams, reality is for these 2 years your life will be really easy because you don't have complex maths kind of stuff. You don't have to think a lot. Nothing passes your brain capacity. So no big issue. But at the end of the day, you're not going to be able to find a job. You're not going to be able to do something for your own. Then you start struggling for next 40 years. So the best solution is, yes, this is difficult, but somehow stay in the stream for 2 years. Somehow struggle and figure everything out. Okay. Then you have a better survival rate in the long run. That is the nature of science. Okay. You have to understand that. So, so science streams in the sense this. Okay. Maths or bio. Okay. Clear? Science stream, the meaning of science stream is that, okay? Because I mean, you have seen like these people protesting for jobs or everything like that, okay? Science people, I don't think that they should go somewhere like that, okay? Because you actually have stuff to do in the stream, okay? Because the pool is small. The people who are competing for the jobs are small, okay? Because everyone can't do this, that's why, clear? So it's difficult, but only for 2 years, okay? So, question 20, the minimum resultant of two forces, okay? Minimum resultant of two forces is 16 newtons and the maximum resultant is 40 newtons. When they act at 90 degrees, find the resultant. So what they're telling is the minimum resultant is 16. How can you get the minimum and the maximum resultant of two vectors? When two vectors are acting entirely in opposite direction. When two vectors are acting entirely in opposite direction, clear? When two vectors are acting entirely in opposite direction, clear? You get the smallest resultant, right? When two vectors are acting in the same direction, you are going to get the maximum resultant, right? That is the minimum and maximum resultant when they haven't given the angle, right? Clear? When two vectors are acting in opposite direction, okay? When two vectors are acting in opposite direction, okay? You are going to get the smallest resultant possible. When two vectors are acting in the same direction, you are going to get the largest possible resultant, right? So, I mean, even when they are acting like this, you can still apply vector triangular theorem, okay? What is vector triangular theorem? You first draw one vector, then it ends here, then it ends here. From where it ends, you draw the next vector, clear? From where it ends, you draw the next vector, clear? So this is the beginning of your diagram. This is the beginning of your diagram. This is the end of your diagram. So the vector triangular theorem tells you get the resultant from the line drawn from the beginning to the end of the diagram, right? So this is a triangle, okay? This is basically a triangle, although you don't see it. Line is a triangle, okay? A line is a triangle with a zero area. Okay? A line is a triangle with a area of 0, okay? Clear? So it goes like this, then returns like this, then the resultant is this, clear? Resultant is this, clear? Okay, it goes like this, then return like this, then this is going to be the resultant. Okay, clear? Which means if the magnitude of this vector is p, if the magnitude of this vector is q, this is going to be p minus q, right? This is going to be p minus q, clear? Then if the magnitude of this vector is p and the magnitude of next vector is q, okay, the resultant would be p plus q. Okay, this is p, this is q, this is going to be p minus q. This is p, this is q, this is going to be p plus q. Okay, clear? So still this is vector triangular theorem. Okay, still this is vector triangular theorem. Okay, so the maximum possible, in that case the maximum possible, sorry, the minimum possible is p minus q. Minimum possible is p minus q, which is 16, which is 16. The maximum possible is p plus q. The maximum possible is p plus q, which is 40, which is 40. Clear? The minimum is 16, the maximum is 40. Now you can find p and q, right? You can solve these two and find p and q, right? Two simultaneous equations. You have two simultaneous equations, 1 and 2, and you can solve for p and q, right? You can solve for p and q. How? Just add the first equation and the second equation. Okay, when you add them you get p minus q plus p plus q, p minus q plus p plus q in this side equals 16 plus 40. Then minus q and plus q cancel out, you have 2p, you have 2p, okay, equals 56, equals 56, okay, 2p equals 56. Then you can get p equals what? 56 divided by 2, 28. P equals 28. Clear? P equals 28. Then here p minus q. P is 28 minus q. P is 28 minus q equals 16. Okay. 28, p is 28 minus q equals 16. Okay. Just use this equation. Then you can get q equals, you take q here, 16 here, 28 minus 16, which means 12. 12. Okay. So p is 28, q is 12. Okay. P is 28 and q is 12. Okay. Now you know the magnitude of p and q, right? Now you can find the resultant when they are acting at 90 degrees, right? Clear? Now draw a new triangle, okay? New triangle for 90 degrees, clear? Now draw a new triangle for 90 degrees and get the answer. Okay, write this down. So maybe let's do it this way. After that, question 14 is very difficult. Okay, question 14 is very difficult. I need you to try that for a moment. Maybe finish this question. I'll give you the interval now. Just maybe 15 minutes. So let's start at 10:30. Let's start at 10:30. Okay. Let's start at 10:30. I need you to finish this. Then take the interval and try 14. You may not be able to get answer for 14. Okay. The ideally you won't be able to get the answer for 14, but I just need you to try. Okay. Just play around with the values and try to come up with some kind of answer maybe. Okay. Clear? Just because before you have to always try before I start explaining. Okay. Then only you would understand it properly. That's why. So you won't be able to get the answer for 14, but I need you to try. Okay. Try question 14. And online students, if you have any questions until now, mention in the chat. Okay. So the next question, okay? The next question. So until now, things were simple. Why? These are 90-degree stuff, right? Okay. Until now, okay, for all the questions until now, things seemed simple, okay? Things seem simple because we are always working with 90. So even for this question, now we have p minus q equals 16, p plus q equals 40. So eventually p becomes 28, q becomes 12. Now the question is, what happens when they're acting at a 90-degree angle? Okay, now the final question is, what happens when they're acting in a 90-degree angle? So, and there was a question, what happens if I draw like this? In a question like this, there were some questions. What happens if I draw like this? They are just talking about 90 degrees. So if someone decide to draw 12 like this and think 5 is like this, what happens? There was a question, okay? If someone draw, okay? If someone draw 12 like this, then 5 like this, okay? Clear? If someone draw 12 like this and 5 like this, okay? Correct, okay? Because it should be correct according to your diagram, okay? So there's no rule like you have to draw 5 like this and 12 like this. No. When if they properly mention east north, then you should. See here, I think they mention 3 east, 4 north. Then yes, okay? Then yes, you have to draw things properly, okay? But in this case, it's just 12 and 5 perpendicular. That's all. Okay? In that case, just draw 12, then draw 5. No big issue. Your answers should be correct only according to your diagram, okay? Clear? Your answer should be correct only according to your diagram. That is sufficient, okay? Okay? Correctness your answers according to your diagram would be sufficient. So in this case also, they are just telling when 28 and 12 is perpendicular, right? They are just telling when P and Q is perpendicular. That's all. Clear? They are talking about when P and Q is perpendicular. So just draw them as perpendicular. That means draw 28, draw 28, okay? Then draw 12. Draw 28, draw 28, okay? Then draw 12, okay? They are perpendicular, clear? 28 and 12, P and Q. The answer is, now the question is when P and Q is perpendicular, clear? So this is the resultant then, okay? This is the resultant. Now you know what to do, right? If the resultant is R, if the angle is theta, what you can do first is R squared equals 28 squared plus 12 squared, okay? R squared equals 28 squared plus 12 squared, okay? And at Excel people, you have to work on not only the logbook, like simpler calculations, okay? You never had that requirement, right? I mean, you never had that necessity to, like, even to think what is 28 squared, right? You had the calculator. So you have to be like, I mean, just don't worry about that, okay? Just don't worry about that because it just take like 2 months to be okay with this, okay? Clear? Even the local level people are not very used to the logbook, okay? You didn't use logbook to a great extent, okay? So there's a very small gap, okay? That means at the moment, even the local people don't know how to use the logbook. They know how to use that, but don't have a good practice on that. So it's not a huge gap, okay? It's just a smaller gap. So it's not going to be an issue, but you have to work on calculations, everyone, okay? Basically everyone. That means, if possible, try to think what is 28 squared. Try to assume what is 28 squared. Think what is 12 squared. Just work on your calculation abilities, okay? Just work on your calculation abilities, okay? These days you don't have like very strict other work to be done, right? So just work on your calculation. Just work on improving your calculation abilities, okay? Clear? Because you can't use the logbook always. You have to be able to do calculations in your head as much as possible. Otherwise, even for very small calculations, you'll be using the logbook, okay? I have mentioned this in the first days of the class too. Okay. I have mentioned this in the first days of the class too. That means like in my physics class, my teacher asked to like try these kind of stuff. Like you when you're going in the vehicle, like you can see vehicle number plates, right? Okay. For take a vehicle number plate, maybe 24, 36 or something like that. Take this and try to multiply them. Try to multiply them. So why in the vehicle? Because there's a lot of distractions. Okay. And at the same time, you have to remember everything. Just do long multiplication here. Okay. Everything in head. Okay. Everything in head. Not going to be very easy. Clear? In a disturbed environment, it's not going to be very easy. What he asked me to do is just do these calculations. Not always, just like at least 1 or 2 per day. Just look at some kind of random number plate. Just get this number, then multiply things in your head. Ideally, long multiplication. That means you multiply 36 by 4. Then you keep it there. Then you multiply 36 by 2. Then add them. Okay. When you do that in your head, it's not your calculation abilities that improves. It's your short-term memory that improves a lot. Okay. It requires a lot of short-term memory for this. Okay. This may be quite simple. Why? It's 2 and 4. Okay. So this improves your short-term memory a lot. So even for calculations, if you are unable to do calculations in your head, what you're lacking is not mathematical ability. What you're lacking is the short-term memory. Okay. Clear? To do calculations in your head, what you need is your short-term memory. So this is a very good way to improve your short-term memory. If you do this for like 2-3 months, then your short-term memory will be really sharp. It helps a lot. Because even in A-level questions, you have to read a whole text, remember the values, then do the calculations. You can't always go and read the text again. It takes a lot of time. So the key components of A-level results is the short-term memory. Okay. It is a very key component for A-level results. So this is a very not stressful way. Okay, this is not a stressful thing that where you have to stay at home and take like 1 hour and do. It's not things like these cannot be improved like that. It should be very natural. Okay, so just do this maybe. Okay, look at a number plate. Okay, and when you're doing this in the road, more components are there. Now you don't see this anymore, okay? Vehicle don't stay there until you do the calculation, right? The vehicle moves. So now first of all, you have to remember what was my number? Okay, 2436. Now multiply 36 by 4. Now multiply 36 by 2. Now shift, add. Okay, you know how to do a long multiplication, right? Okay. You may struggle a lot, okay? In the beginning, you may struggle a lot. You can't do it. Why? You look at the number plate. Now the number plate is not there. That vehicle moves. Now you have to remember everything in your head. Now you have to do calculations. While doing the calculations, you are on the bus or on your car, in your car, which means a lot of distractions. Now with all those distractions, you still have to remember these. Now you have to do the calculation. Okay. Now you have to do the calculation in your head. Okay. It's a lot of stuff in that case. Okay. It's very difficult. Okay. In a disturbed environment like that, it is very difficult. But you keep doing this for 3 months. Slowly, you may be able to figure that out. Then maybe like if you keep doing this for 6 months, you see the number plate, you see the answer. Okay, that ability grows. Okay, that ability grows. You see the number plate, within like 5 seconds, you see the answer. So with that level of calculation ability, you're going to be really fast than others. Okay. Clear? You are going to be extremely fast than others. So these kind of very small stuff matters for A-levels. Not how much time you study. It's not the thing that decides, okay? Small abilities like this, okay? So work on them, okay? Definitely work on them. Some people may think, I don't see that very useful. But when after 6 months, it's going to be late. After 6 months, it's not a time to do this. Then already the gap is there with the other students, okay? Between the people who did this and didn't do this. Okay. So just start now. Okay. Just start now. Maybe try these things. It's a headache when you try to do this in the vehicle. Okay. It's a headache. Okay. Because you can't remember the values. All of a sudden you hear some noises. It's going to be a lot of headache. Okay. But if you somehow like keep doing that, okay, if you somehow keep doing that, then eventually you are going to be good at that. So being good at that doesn't mean you are good at long multiplication. You can just do that by hand, right? No point of trying to do that in head and get a wrong answer. In A-level paper, the best solution is just write and multiply, okay? Don't try to do this in head. But the ability you grow is not this. The ability you grow is short-term memory, okay? Clear? Short-term memory is I can call maybe it is between in the top three key components for A-level result, okay? Short-term memory, very important. Clear? So do things like that, okay? It's not the time, the number of hours you study, the smaller things you do in a daily basis, okay? Clear? Clear? Smaller things you do in a daily basis. That's what decides like your A-level results, okay? So here, r squared equals 28 squared plus 12 squared, which is going to be 928. 928. R squared equals 28 squared plus 12 squared, which means 928. Then R is square root 928. For this, you have to use the logbook, okay? Square root 928. For this, you have to use the logbook. This gives us 30 point 30.46. Okay, this is going to be 30.46. Okay, clear? 30.46. This is the resultant. Then you have to define the angle. Maybe use tan theta. Okay, use tan theta. Tan theta is 12 over 28. Tan theta is 12 over 28. Tan theta is 12 over 28. That means 0.428. Now tan theta is this 0.428. Now you have to use the logbook to find theta, okay? You have to use the logbook to find theta. Theta is 23. Theta is 23 and 10 minutes. Clear? Okay. Now only it becomes a complete answer, okay? Now only it becomes a complete answer. Okay. Clear? Which means 30.46. 30.46. Okay. 30.46. Angle 23 and 10 minutes. Okay. Clear? 30.46. This is the angle. Clear? Okay. This is a complete answer now. Okay. This is a complete answer. Okay. Next. Now, is it clear up to this point? Is it clear up to this point? Okay. So here all the questions seems easy. Why? Because they are 90 degrees, right? All the questions seems easy because they are 90 degrees, right? They are always talking about two vectors acting in 90 degrees, right? Now comes the problem. I think question 14. Two forces of 10 newtons and 6 newtons act at a point. Find the resultant when the angle between them is 60. That means, pay attention now. If 10 newton is in this direction, if 10 newton is in this direction, okay, 6 newtons is in this direction, okay, 6 newtons is in this direction, okay. Now, this angle is 60. That is the meaning, right? 10 is in this direction. This is the direction of 10. This is the direction of 6. Okay. This is the direction of 10. This is the direction of 6. And the angle between them is 60. Okay. Clear? Angle between them is 60. Okay. So let's draw a triangle, a vector triangle again. Now you have Now you have 10. Okay. Now you have 10. From this point starts 6. Okay. From this point start 6. Okay. You have 10. Then this is the direction of 10. This is the direction of 10. Okay. Then you have 60. Then you have 60. Direction of 10. From where it ends, you draw the next vector. That's how we apply vector triangular theorem. From where it ends, we draw the next vector. Now this is the beginning of your vector diagram. This is the end of your vector diagram. Now what is going to be the resultant? This is going to be the resultant, right? Clear? This is vector triangular theorem. Okay. You get one vector. From where it ends, you draw the second vector. This is the beginning of your diagram. This is the end of your diagram. This is going to be the resultant. Now it's not very simple anymore, right? Because there's no 90 degrees here. So you can't directly use 10 and 6 to find R, right? You can't directly use 10 and 6 to find R anymore, right? Clear? Clear? It's not straightforward anymore. So all we know is how to get answers when it is 90 degrees, right? All we know is how to get answers when it is 90 degrees. Clear? Clear? So, all we know is how to get answers when it is 90 degrees. So let's create a 90 degree triangle. See, using these two lines, I can create a 90 degree triangle, right? Now if I find this length, L1, okay? And if I find this length, L2, okay? Now if I find this length, L1, if I find this length, L2, again I can find R, right? Why? R squared would be this length, L1 squared plus this length, L2 squared. Clear? R squared will be this full length. Clear? Which means L1 squared plus this full length which means L2 squared, considering this triangle. Clear? Got the idea? Clear? Now I'll call this length x and this length y. I can use this triangle, right? I can use this triangle to get x and y, right? Clear? We can use this triangle to get x and y, right? Clear? Okay. How? You can write sine 60. You can write sine 60 for this length over this length, right? You can use sine 60 for this length divided by this length. Clear? Y over 6. Okay. Then you can use cos 60. Then you can use cos 60 for this length divided by this length, right? X over 6. Okay. We can write sine 60 equals y over 6. Y over 6. Okay. Then we can write cos 60 over x over 6. Okay. Clear? So I can write y equals 6 sine 60. Okay. X equals 6 cos 60. Clear? We can write y equals 6 sine 60. We can write x equals 6 cos 60. Okay. Now what? Okay. Clear? Y equals 6 sine 60 and x equals 6 cos 60. Okay. Now what? Now, now you have L1 and L2, right? Now what is L1? L1 is 10 plus x, right? 10 plus x. X means 6 cos 60, okay? L1 is 10 plus x. 10 plus 6 cos 60, okay? Then what is y? Or L2? L2 equals directly y, right? L2 directly equals y. Clear? What is that? 6 sine 60. 6 sine 60. Clear? Now you have enough information to find r, right? Why? R squared equals L1 squared plus L2 squared, right? So you can write R squared equals, what is L1 squared? This 10 plus 6 cos 60. 6 cos 60 squared. Okay. 10 plus 6 cos 60 squared plus, this is 6 sine 60. This is 6 sine 60 squared. Okay. This is 10 plus 6 cos 60 squared. This is 6 sine 60 squared, right? Which means L1 squared plus L2 squared. Clear? Now you can find the answers, right? Clear? So in that case, it's a long run, okay? It's a long run in that case. But I mean, we are not going to use this method in the future. We are going to use a different method, okay? We are going to use a different method, maybe like, I mean, yes, we have mathematical solutions. We definitely have mathematical solutions like sine theorem, cosine theorem, okay? We have different solutions like you may know, right? Sine theorem, cosine theorem kind of stuff. More mathematical theorems, clear? We have methods like that. You may know, right? Okay. Some people may know, some people may not. You can use sine theorem and cosine theorem kind of stuff. But I mean, by next week, we are going to derive a new equation for this, okay? We are going to derive a straightforward equation for this. Clear? So with that straightforward equation, we can easily go for answers, okay? That means now you should understand the problem here. Vector triangle is very straightforward, but when it comes to solutions, it takes a lot of work to solve, right? Sometimes, if it is not 90, it takes a lot of work, right? Clear? If it is not 90, it's gonna cost a lot of time, right? Clear? That is one of the problems, okay? In vector triangular theorem. So still it is not the time to learn the next theorem, but next we are gonna learn vector polygon theorem. Then we are gonna learn a theorem where we can get answers without drawing things. Okay, now the problem is, for now, the only way we are going to resolve vectors is, or solve vectors is, using diagrams. But diagrams cost a lot of time like this. See, now you can do the calculation, right? Now you can do the calculation and find R, but still it's a lot of work, right? So I mean, this question, this is not how are we going to do this question. I just needed to show you the difficulty of that. Okay, when we try to handle vectors always using diagrams, okay? Clear? Handling vectors always using diagrams is not a good thing, okay? So we soon need a equation to solve them, okay? So next, let's think about that. For now, maybe you can write this down as the method. I'm not going to continue through this method, solve everything and do everything, because this is not the actual method that we are going to follow to get answers for this, okay? It's going to be different. Okay, so for now, you can write this down. Question 14. There are going to be a better and easy method to get answers for questions like this. For now, let's think, okay, assuming we only know vector triangular theorem, this is the solution, okay? Okay, if we only know vector triangular theorem, this is the solution. You have 10, you have 6 and 60 degrees here. That is the problem. Clear? So what you do is you only know how to work with 90-degree triangles, okay? Clear? So what we are going to do is we are going to create a 90-degree triangle like this. We are going to create a 90-degree triangle like this, okay? Then we are going to find x and y. Clear? That using this 90-degree triangle. Using this 90-degree triangle, we are going to find x and y. How? Sine 60 means y over 6. Cos 60 means x over 6. Clear? Then you can tell y equals 6 sine 60, x equals 6 cos 60, okay? Then we can write x here, y here. So we can tell this length is 10 plus x. That means 10 plus 6 cos 60. This is 6 sine 60, okay? Clear? 6 sine 60. Now you are going to apply again r squared equals 10 plus x squared, which means 10 plus 6 cos 60 squared plus 6 sine 60 squared. Clear? Okay. So let's just keep it like that. I'm not going to solve that further, because this is not how are we going to handle a question like this. Okay. Okay. I mean, specifically if they ask you, okay, solve this only using vector triangular theorem, then you have to follow this, okay? Clear? Solve this only using vector triangular theorem, then you have to use this. Any questions until now? Any questions? No? No? So for maths people, you may be able to use cosine theorem, but for that you again may need 120, right? Cos 120 kind of stuff. Okay. Or maybe sine theorem. Yeah, there are different solutions like that, but that's not how are we going to do this. Maybe today or next week we'll learn that. Okay. Next part. Next part. And there are like I think some existing students in the class who joined just to get vectors clarified again. If you find resolving vectors part difficult, yesterday I did another video of resolving vectors. Okay, I'll provide that in the group. Okay, I'll provide that in the group, resolving vectors part. Okay, next. Now all we know is how to deal with two vectors, right? You draw the first vector, then you draw the second vector, then you get the resultant. This we call the vector triangular theorem, right? This we call the vector triangular theorem. Then what if we have more than two vectors? What if we have more than two vectors? What if we have more than two vectors? Maybe three vectors. We are going to apply vector polygon theorem. Okay, we are going to apply vector polygon theorem, which is not actually a new thing. Okay, it's the same theorem. That means these are very practical. If you walk like this, then like this, then like this, okay, what actually happened was you went from here to here, right? You went from here to here, right? So this is vector polygon theorem. Okay, nothing new. Okay, if you walk in this direction, then that direction, then in this direction, what actually happens is, what is the final result? That is the meaning of a resultant, right? What actually happens? What is the final result? That is the meaning of a resultant, right? So the resultant would be this, right? If you walk from here to here, then from here to here, then from here to here, what actually happens is you get a resultant like this, right? Clear? So this is vector polygon theorem, okay? That means when you have more than two vectors, instead of drawing a triangle, draw a polygon, okay? Draw a polygon, okay? How? Assume you have 3 newtons in this direction, 4 newtons in this direction, and 6 newtons in this direction, okay? 6 newtons in this direction. You just choose vectors in whatever the order you like. You get 6 newtons, draw that. You draw 6 newtons first, okay? You can choose whatever the order you like, okay? First draw 6 newtons. It's gonna start here, end here, okay? Who's the next one? This one, right? Next one would be this. Draw that one. Draw that one. Clear? Draw the second one. Clear? Draw the second one. Okay. Next, this one. Clear? Next, this one. Okay. Clear? First this one, then where it ends you draw this one, Then where it ends, you draw this one. Okay. Now, what is the beginning of your diagram? This, right? This is the beginning of your diagram. What is the end of your diagram? This. This is the end of your diagram. Clear? Then how would you get the resultant? This is going to be the resultant, right? This is going to be the resultant. Clear? Okay. The line you draw from beginning to end. Clear? The line you draw from beginning to end will be the resultant. Clear, everyone? Clear? So, I mean, like, if someone asks you to prove this vector polygon theorem using vector triangular theorem, okay? If someone asks you to prove this vector polygon theorem using vector triangular theorem, you can try something like this. You first draw one vector, okay? Then you draw the second vector. Okay. Then from vector triangular theorem, this is the beginning of those two vectors. This is the end of these two vectors. Then this is going to be the resultant, right? This is going to be the resultant. Clear? This would be the resultant. Clear? Now I'm going to forget these two guys, okay? Now I'm going to forget these two guys. Why? I have a resultant representing them. Clear? I'm going to draw this, then complete a triangle. Then I'm going to forget these two. Clear? Okay? Then I'm going to forget these two. Clear? Because instead of these two, now I have this one. Clear? Instead of these two, now I have this one. Clear? Now, I'm going to draw a triangle for this and this. For two vectors, you can always draw a triangle, right? Now, I'm going to draw a triangle for this and this. Clear? Clear? So, this. And I'm going to draw a triangle like this. Now, I'm drawing the triangle for this and this. For two vectors, I can always draw a triangle, right? So, vector 1, vector 2. What is the result of that triangle? Result of this triangle would be this. Clear? Resultant of this triangle would be this. Clear? This is the resultant of that triangle. Now, if you see, this blue color line is entirely useless, right? Clear? Clear? What you got was actually this, right? Clear? So you can use two triangles, but at the end you actually get the same polygon, okay? Clear? So yes, polygon is just a result of multiple triangles, okay? Polygon is just a result of multiple triangles. Clear? You combine one triangle after the other. Clear? Clear? You first draw one triangle for two vectors. Clear? Then connect it with another triangle. What you actually get is the vector polygon. Clear? Got the idea? What you actually get is the vector polygon. Okay? So this is the second theorem, vector polygon theorem. So we have derived two theorems by now. Vector triangular theorem, vector polygon theorem. Both have the same issue. What is the issue? You need diagrams for them, okay? So eventually what we are going to do is we are going to learn these diagram based concepts. Then we are going to learn a concept without diagrams, okay? Clear? So is it clear up to this point? Yes? Okay. Ask if you have any questions. Go to on page 3 of your tute. On page 3 of your tute, go to question 4. Go to question 4. 4, 5, and 6. Maybe try these 3. 4, 5, and 6. Try these three. Page 3, question number 4. Page 3, question number 4. While you're answering that, I mean, there was a question online. I mean, when the angle is maybe larger angle like this, there was just a question. I'm gonna answer these kind of stuff later with proper questions. Assume if the angle is like this, maybe 120, how to get the resultant? This is 5, this is 3, how to get the resultant? Still possible, right? I mean, how? I mean, you just draw 5 first. You just draw 5 first. This is the direction of vector 5. This is the direction of vector 5. Then you draw 3, right? And the direction of 3 is like this. 120, okay? Clear? This is the direction of 5. It ends here. Then you draw like this at an angle of 120. Then what you need is this resultant, right? Clear? So maybe try to figure out a method. How? Just draw the triangle like this now. Okay? Use this length to find this and this. From this length, subtract this guy, then you get this. Now you know this and this, so you can find this. Like that. Okay? Later when we are doing questions, we'll analyze these kind of stuff. But see, still possible, okay? These are not in the physics syllabus, okay? This is you work around with the things you learn from O levels to come up with an answer, okay? So that is the main part of A levels, okay? I mean, the answers are not straightforward, okay? In O levels, you learn something, you apply that. You again learn something, you apply that. In A levels, you just have a question. You won't even know which topic it belongs to. Now you have a bunch of theories you learn. Now you use some kind of a thing that you already know and bring that to the question, okay? To figure that out. It's not like O levels. In O levels, you have a topic for each question, right? The log question, okay? So you can apply the theorems you learned in that small log lesson to that. Clear? Like that. In A levels, there's no that kind of very strict topics. You just have a question. You bring something you know to handle that. Okay, clear? See, try quickly go through this stuff. And like you can cover vectors like this here. But I mean, even for the previous lessons, we'll arrange sessions to do them also. But if you like, you can even watch the recordings and catch those parts. Okay, it depends. Like, okay, we can arrange a weekly session to cover the first lesson, units and dimensions. Then cover the next lesson, measuring instruments, like that. So it would go in a weekly basis. It would go in a weekly basis, slowly, one after the other. But I mean, if you have time, okay, you can just request the recordings from us. Okay, even online students. Okay, just use the hotline. Physical students, you can just ask me. You even have the option of getting the recordings from us and watch them. Okay, while joining the Tuesday class. Okay, yeah. That way, if you have time, you can finish things whatever you missed faster. Okay, it's entirely up to you. Okay, yeah. You can even choose to finish whatever the things you missed really fast by watching the recordings. These days, you are at home, right? School registrations and some kind of stuff may happen, but it's not gonna matter a lot, right? Okay, so if you like, you can get the recordings and finish everything really fast. Okay, yeah, that is also a solution. Okay, that's also a possible solution. It's up to you. Okay, how you cover those 3 months content, it's up to you, from through our sessions or maybe through recordings, whatever the way you like. Okay, but the must is join the Tuesday class. Okay, clear? Because it's going to be a new part from this week. Okay, we are going to learn a new part from this week. Okay, so here, question 4. Now see, it's a plus b plus c, quite simple. You first draw vector a. You first draw vector a. Then after that you first draw vector a. Then you draw vector b. Then you draw vector b. Then you draw vector c. Things are not given with absolute value, so you can't draw a perfect diagram. Okay, so just draw them like this. A, from where A ends you draw B, from where B ends you draw C. Okay, then what is the resultant? This is going to be the resultant, right? This is going to be the resultant, which means vector A plus vector B plus vector C. Clear? This is going to be the resultant. Vector A plus vector B plus vector C. That's all. Clear? You draw the first vector, where it ends you draw the second vector, where it ends you draw the third vector. Clear? A plus B plus C. Clear? I mean, now the next one you have A plus B minus C. Okay, check the next one. What you have is, in the fifth one, what you have is A plus B minus C. Okay, you have A plus B minus C. So the problem is we never learned vector subtraction theorems, right? We never learned vector subtraction theorems. There is no actual vector subtraction theorems, okay? What we do is we add the negative vector. That means this same thing you can write as a plus b plus. This same thing you can write as a plus b plus minus c, okay? Clear? The same thing you can write as a plus b plus minus c. Instead of minus c, you can use plus minus c. That means what you are going to do is not subtraction, adding the negative vector, okay? Adding the negative vector, okay? That means this is vector A. You have vector A. This is vector B. You have vector B. This is vector C. Okay. Now what is negative vector of C? Same vector but opposite direction. Okay. Negative vector of C is same vector but in opposite direction. Clear? Okay. A, B, this is C. This is the same vector but in opposite direction. Clear? Minus C. Okay. Minus C. This is C. This is minus C. Okay. So now what I'm going to do is I'm going to add these three. Okay. What I'm going to do is I'm going to add these three. Okay. So first start with vector A. So first start with vector A. Then it ends here. It ends here. Then draw vector B. Then draw vector B. It ends here. Then draw vector minus C. Okay. Then draw vector minus C like this. Okay. Now this is the beginning of the diagram. This is the end of the diagram. Okay. This is the beginning of the diagram. This is the end of the diagram. Then the resultant is this. Okay. Then the resultant is this. Okay. Always the resultant is the line you draw from the absolute beginning to absolute end. Okay. So you draw one vector. From where it ends, you draw the second vector. From where it ends, you draw the third vector. Then the resultant would be the line you draw from the beginning to the end. Okay. Beginning to the end. Okay. Clear? Okay. There was a question, what if we use the cosine rule learned in Edexcel to handle questions like this? No issue. This is actually the proof of cosine theorem. Okay. You move forward with this, you get cosine theorem. Okay. So yes, I mean, just feel free to use whatever the method you like. But in the future, we are going to learn a better method than this. Okay. So no worries about that. Okay. A, B, and minus C. Okay. Clear? A, B, and minus C. Okay, in A levels, what actually matters is you somehow getting the correct answer. Okay, clear? No matter, I mean, you can like either use maths or you just can assume, or you may remember the answer, or you may even can copy. Okay, do whatever you need, getting the correct answer. That is the key component. Okay, clear? That is the key component. I mean, in our class, these are not good things to tell. I mean, our school days, I mean, in my class, I mean, in our class was actually special. Our class has Ananda College, all top 3 results that year I think we had from in our class, including Island First and all. Okay. So, I mean, for the first 4 terms, I was the class first. For the last 2 terms, Tarusha was the class first, and he actually ended up being Island First. Okay. So, it is a very good story to learn. Okay. I mean, those days, my marks were like this from the beginning. Okay. Tarusha's marks were like this. At the first term test, I had 80 something. He got 30 something for maths. Okay. So things change. Okay. That's something you have to remember. Okay, for the first term test, in the first term test, I got 80 something for the 88 or something like that for the maths paper. He got something around 30 something for the maths paper, but the person worked a lot. Okay, so my marks were like this. You can't go above 80s. Okay, you can't go above 80s. It is pretty difficult at Ananda College. Papers were difficult, but the person kept growing. Okay, so in the fourth term test, that means the fifth term test, he actually passed me. Okay, then ended up being island first. Okay, so huge growth curve. Okay, huge growth curve. That means I can remember my strong subject was physics until the fifth term test. I had the highest marks for physics. In the sixth term test, last term test, I got 99 for physics. Okay, Tarusha got 100. Okay, so so growth curves are very random in A level. These are actual stories. You can just check. Okay, I can't just lie about having island first in my class. Okay, you can easily check. Okay, so so the growth curves are, you never understand the growth curves in A levels. Okay, pretty complex. When some people start understanding things very late, then end up being island first. Okay, clear. Some people start figuring out things very late. Okay, after like 1.5 years into A levels, some people start getting marks. For the first time, they get somewhat good marks. Sometimes maybe after 1 year, for a 1 year they struggle, can't get marks. Then they start showing slight improvements after like 1.5 years. Then some people like that end up being district first, island first, like that. So the growth curves are very complex. Not like, because A levels is complex. As a result, you don't know, like the class 10th or 15th you have may ended up being like class first towards the last term test. Okay, so growth curves are very different. The reason is actually some people decide to work hard at different levels, right? Clear? For me, this was enough for me. Okay, for me, that was enough. I had many other plans, like I did 2 other sports. Okay, so what I needed was maintaining. Okay, what I needed was maintaining my marks. Okay, so still like anyways, it's the same university, right? Getting into university tomorrow too. So my target was different. I maintained a very good mark until the last term test, so that I know I get 3 A's while doing my sports and everything. So that was enough for me. For this person, he was struggling at the beginning. Okay, towards the middle, started improving marks at a very high rate. I think in the last term tests, out of 300, you get three papers, right? Out of 3 papers, I think in the last term test, his total was like 298 or something like that. Those days, Ananda College papers were like 5 times difficult than A levels. Okay, so the total was like 298 out of 300. So most probably in A levels also, out of 300, I think he may have like at least 296 or something like that. Okay, out of total marks. Okay, one of the highest TCH scores ever, 3 point something, 3.3 or something like that. Okay, so that's how things end up. Okay, starting at 30 something for the first term test. Okay, so we never know. Okay, in A levels, we never know. Some students may have joined later because they didn't understand things at the beginning. So we never know. Okay, we never know what happens in A levels. It's a very, the growth curves are very mysterious in A levels. Okay, so that is one thing you have to remember. Okay, so so did you understand this? Did you understand this? Okay, so this is vector polygon theorem. Clear? This is vector polygon theorem. So I think we can stop here for today. So what I need you to do is just go through the theory again a bit. You have a slight understanding about vectors now, but next Thursday also the sessions will happen. But this Tuesday at 3, I need everyone to join. Okay, I need everyone to join this Tuesday 3, because we'll be doing a small amount of vectors at the beginning for half an hour, but after that we'll be moving to motion. Okay, we'll be moving to motion. So maybe go through the vectors and just let us know. Okay, if you are missing any class on Thursday, you may have registration at schools or something like that. So just let us know. Okay, and be very intelligent when you're changing schools. Okay, if your current school doesn't care about 80% a lot, just stay there. Okay, that's my advice. Okay, 80% attendance. If your current school don't care a lot about your 80% attendance. From my point of view, the advice is just stay there. Okay. You don't need a better school name. All you need is a result. Okay. Clear? 3 A's is better than, okay, 3 fails at a good school. Okay. Clear? So the key component is, at the end of the day, this is a huge syllabus, very difficult to finish. From your point of view, you may have a lot of work. So going to school every day, 8 hours per day, with the transport time and everything, it usually costs 8 hours per day, right? For a normal person, like average number of hours that they can work efficiently is also 8 or 10 hours. Okay. Clear? So maybe if your school doesn't care about 80%, that's the best school to stay. Okay. Don't seek for higher names, better names, or anything like that. Nobody cares. Okay. Nobody cares. You never go to a doctor and ask the level, ask the school, right? Okay. Clear? You never go to a doctor or an engineer and ask, okay, what is your school before giving the project? No, right? Nobody cares your school. Okay. Nobody cares. What matters is the A-level result. So for A-level result, maybe that 80% attendance thing plays a huge role. Okay. Clear? Because whenever you are struggling, you can stay home and do some work and catch up with the things. It is a huge benefit if you can do. Okay. So when changing schools and all, from my point of view, the key component to check is the strictness of that 80%. Okay. Clear? Something to remember. Thank you.